Good morning, guys. Good morning. Okay, I was already on the right page. I promise. I don't know what happened. But yeah, welcome. We're going to be talking about the 2018 the real FRQs. Today we're going to tackle numbers 2, 5, and 6. Yeah, I'll check it out right now. And hopefully we have enough time. Let's see. Let's get started. Number 2, we have a particle moving along the x-axis with a given velocity between 0 and 3.5 seconds. We are given the position. We were told that on the x-axis, it's at -5 whenever t is equal to 0. Find the acceleration of the particle at t is equal to 3. Okay, well, because this question is not meant to be done by hand, all you got to do is use your derivative function on the calculator, math 8, and get the derivative. The derivative of the velocity at t is equal to 3 comes down to -2.118. Simple as that, 1 point. B. Oh, and you know what? You guys got to try it. Because it would be a shame for you to miss points, easy points like this, where you just type it up in the calculator because you're messing up with something. A parentheses, a negative. So just try it. B. Find the position of the particle at t is equal to 3. Well, here's the generic formula. If you want to find the value of a function and you're given a derivative, like in this case, you're going to be using the integral from a to x of the derivative plus f of a. This is your initial condition. So in the context of this problem, we want to find s of 3, which is going to be given by the derivative from 0 to 3 of the velocity plus, well, let's just say -5. Now, again, keep in mind that your setup sometimes is not going to be in order. In this case, it is, because the initial condition was given when t is equal to 0. But yeah, that's the setup. Set it up. That's 2 points right here for setting it up. And practice typing it in the calculator. This is going to be -1.7602. Maybe write a little sentence, a little blurb about what this means. That at t is equal, whenever t is equal to 3, the position of the particle is -1.7602. But I'm moving on. C. And I got my paper, so I don't have to scroll up and down. But they want us to evaluate the integral from 0 to 3.5 of v of t dt. Again, just type it up in your calculator. 2.844. They also want me to evaluate the integral from 0 to 3.5 of the absolute value of the velocity, which comes down to 3.737. 1 point right there. Interpret the meaning of each integral in the context of the problem. Well, the first one is talking about the displacement. Displacement of the particle and you can phrase it however you want, but I'm going to say that it's during the first 3.5. Man, it's not seconds, so I don't know if I'm going to be wrong by saying seconds. So maybe I shouldn't say that. The displacement of the particle on the interval from 0 to 3.5. So again, displacement just means like how much your position changed, right? Because the position used to be at -5, and we don't know how the particle moved, but at 3.5 seconds, just for the sake of units, now the particle is, well, over here. We know that it started here and it ended here after 3.5 units of time. The second one is the total distance traveled. Total distance traveled on the interval from 0 to 3.5. We don't know what the particle is doing, right? Because the particle could be here and it could move forward and then it could move a little bit backwards and then it could move forward again. We don't know, but we know that it lands at 2.8. But because we're also tracking the reverse distance, that's why the total distance is much greater, right? 3.7. So there it is. D. A second particle also moves along the x-axis, and here's the position of the particle. And it's also moving from 0 to 3.5. At what time are they moving with the same velocity? So first of all, we got to get velocity, right? The velocity of the second particle is 2t minus 1. We already have the velocity of the other guy. So when does the velocity of the other guy equal the velocity of this guy? This is the original one, right? I don't want to write the whole equation out. I don't need to. I'm just going to write v of t. Graph them on your calculator and figure out the point of intersection, which is this, 2 points. Okay. Let's see. We already did that one last time. We did number 4. Okay, number 5. Let f be the function given. Find the average rate of change from 0 to pi. Okay, average rate of change, nothing too bad. I'll do it right here. If we're going to find the average rate of change, then we're going to have to do f of b minus f of a divided by b minus a. If you plug in pi, you get e to the pi times cosine of pi minus e to the 0 times cosine of 0 divided by pi. Cosine of pi is negative 1. E to the 0 is 1. Cosine of 0 is 1, which means the average rate of change is negative e to the power of pi minus 1 over pi. You got to get it right. It's 1 point. One mistake disqualifies you. Whoa, 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 whoa. Okay. B. Let me just zoom in. You have the problem in front of you. What is the slope of the line tangent to the graph at x equals 3 pi over 2? Okay, so just the slope, which means we need to get the derivative. So let's go ahead and get the derivative. The derivative is first times the derivative of the second plus the second times the derivative of the first. Plug in your 3 pi over 2. F prime of 3 pi over 2 is e to the power of 3 pi over 2 times sine 3 pi over 2 plus cosine 3 pi over 2 e 3 pi over 2. So this gives me, well, sine of 3 pi over 2 is negative 1, which means we now have a positive. And cosine of 3 pi over 2 is 0. So the whole thing is 0. There's the slope of the tangent line. 2 points. Okay. Okay. What now, computer? There we go. See. Find the absolute minimum value of f from 0 to 2 pi. Okay. Well, let me go ahead and take my derivative that I just found. My derivative was, or is, negative e to the x sine of x plus e to the x cosine of x. And you can change the order of the product of two terms. But anyways, you want to get the derivative equal to 0. Right? You have to show that. because that's how you find your critical points. Okay, I'll just move the 0 to the other side. Notice how they both have an e to the x. So we're going to factor that out. Then split the two components using the zero product property. Now e to the x equals 0 is not possible. E to the x is never going to be 0. It has a horizontal asymptote. But for the other one, you need to figure out a value of x when cosine of x equals sine of x. If you got to know your unit circle pretty well. This is going to happen at pi over 4 because they're both root 2 over 2. And there is a second angle, 5 pi over 4. They're both root 2 over 2, but they're negative. Those are your critical points. So if you want to find the absolute minimum, you're going to have to test your critical points and your endpoints. And we're going all the way to 2 pi. Now you need to plug them into this function. You need to plug them in. Oh, we actually have f of x, right? So e to the x cosine of x. We're looking for the minimum. If you plug in 0, e to the 0 is 1, cosine of 0 is 1, so you get 1. Plug in pi over 4, you get e to the pi over 4 times square root of 2 over 2. Plug in 5 pi over 4. Well, cosine of 5 pi over 4 is negative square root of 2 over 2. And if you plug in 2 pi, cosine of 2 pi is 1. Oh, wait, it's not e to the x. Silly me. It's e to the 2 pi. So even though you don't have a calculator, it's pretty obvious that the minimum is the negative. There it is. 3 points for that question. Okay. Oh my God. Again, huh? I swear I'm not pressing anything crazy. I'm just working here. Okay. D. So they're giving us that g is a differentiable function. That seems to be important. We're also told that g of pi over 2 is 0. And we are given the graph of g prime. They want us to find the limit as x approaches pi over 2 for f of x over g of x. Okay, so yeah, plug in your pi over 2, f of pi over 2 minus g of pi over 2. So we actually have the equation for f, right? Which is going to be e to the pi over 2 times cosine of pi over 2, which is 0, because cosine of pi over 2 is 0. G of pi over 2, we are given that it's 0. And you have to show both limits equal to 0, because when both components, the numerator and the denominator, equal to 0, then you can apply L'Hopital's, just to check if the limit is truly undefined. So take the derivative. Now for f prime, we already have the derivative. So I'm just going to go ahead and plug in pi over 2. Now for g prime, we're looking for the slope. Let me show you. Oh man, sorry. So because we're given the graph of G prime, super careful. You're not looking for the slope because this graph already tells us the slope, right? Don't think of it as an x comma y graph. Think of it as an x comma slope graph. So like if I say, when x equals pi, all you got to do is look at the coordinate point, and the slope would be approximately, I don't know, 1.2. Right? That's the slope. You're not actually calculating this slope because this is already the graph of G prime. If you were to calculate the slope, you're actually giving me G double prime. So careful. Anyways, we want to find the slope when x is equal to, oh, pi over 2, sorry. Pi over 2, which is here. You might think it's not differentiable, but again, we're not looking for G double prime. The slope is 2 already. That's the slope. Okay. Sine of pi over 2 is 1. Cosine of pi over 2 becomes 0, which means the whole thing just goes away. And there's your limit. 3 points. All right. One more question. I think we can finish. Okay. I'm not going to read the question just to, get it over with. But here they want us to sketch some solutions. Here's the first solution through the point 0, 2. Just follow the slope field. Here's the second solution through the point 1, 0. Just a rough sketch. Okay. Part B. You have it with you. Okay. Since I want to find the tangent line. So here, let's go ahead and find the slope. dy dx equals 1 over 3. And we want to find the tangent line at the point x equals 1. And with x equals 1, y is equal to 0. So plug them in. The slope at the point 1, 0 is 4/3, which means your tangent line is y equals m x minus x1 plus y1, y equals 4/3, x minus 1 plus 0. That's your tangent line. Now use it to approximate f of 0.7. 4/3 times 0.7 minus 1 equals this. You can work on it however you want. I'm gonna make the negative 0.3 into a fraction, 3/10. Cancel out the 3's and reduce the 4/10. That is the approximation of f of 0.7. 2 points for this question, 2 points for A. C. Now we want to find the particular solution given an initial condition. We're going to start with a differential equation. First, we want to separate the variables. Move the y with dy and move the dx with dx. That's your first point. Before I find my antiderivative, let me set it up so that I can be successful. Oh, and I forgot dy. Okay, now you can get your antiderivative. Because the power is more than -1, or I guess less, you can just you can add 1 to the exponent and divide by the new exponent. Same thing, add 1 to the exponent and divide by the new exponent, plus c. Now you can use the condition. We were given the initial condition 1, 0. plug it in. But you know what? Let me rewrite this. It's going to be negative 1 over 0 minus 2 equals 1 over 6 times 1 squared plus c. Well, you're going to get that 1/2 equals 1 over 6 plus c. And let's do two things. One, let's get a common denominator for the 1/2 so that it matches the 1/6, and subtract the 1/6 from both sides. This is going to give us 2 over 6, which is 1/3. That's your c. And now that you have c, let me erase the condition here. Now that you have c, I'm going to go back to the step when I took the antiderivative, but I'm going to write it like this. And we're going to plug in our c that we just found. Okay. First, I'm going to get a common denominator. Multiply the 1/3 by 2 over 2. Next, I'm going to multiply both sides by a -1, but I'm also going to combine the fraction. Notice how I'm keeping the negative on the outside. I'm not going to distribute it. There's no need. Next, since I have that one fraction equals one fraction, you can go ahead and just flip both fractions. Or you can take the long way, and you can cross multiply and do all that stuff. Finally, I can add 2 to both sides, but don't really combine it with the fraction because you don't have common denominators. That's your particular solution. I love these questions because it's a huge chunk of points, and basically, as long as you know your algebra and your antiderivatives, you can get a lot, right? This was 5 points. And in my work in blue, that was just 1 point. The first 4 points came here. So really practice those. And anyways, guys, yeah, that's gonna be a wrap. All of the 2018 questions are completed now. See you guys in class.